Being the other file?
Yes. Like, what you were just drawing on.
Oh, that. Okay.
And then go file.
Yes, I can save this to a file. Unfortunately, you would need Windows Journal to be able to read it.
Oh, okay.
So, but if you want to be able to see this, I record everything. And so you'd be able to recreate everything we're about to talk about
Okay.
if you want to be able to re-see it. Okay? All right. This is L1. This is L2. This is L3. This is L4. Wow, the hardest part about this is drawing it. And unfortunately, if I don't draw it, it's hard to talk about it. So I kind of have to draw it.
Okay.
But it shouldn't take too long here. That's G. This is a typical geometry problem where you basically use the geometry principles that you've learned. Oh my God. Hold on. To figure out all of the angles. Let's see. All right, so that is 70 degrees, and it's the same as that, which is that a J? It's one of the reasons I was trying to get this drawn before you got into the room, was because I know it takes so long to do it. All right.
Sorry about that.
No, that's my problem, not yours. All right, I think we've got everything. Now, let me blow that up and let's solve. Now, the first thing to know when you're solving these kind of problems is you do not have to solve them in the order of the letters. You don't have to solve A first, B second, C third, and so forth. Basically, you just kind of solve what you can solve. For example, what is J?
J is 70 degrees.
Correct. Now, I'll make a list over here, but I'll also draw it on the diagram. In other words, that's a no-brainer.
Right. So is C. That's 52 degrees, right?
Do we know D? Hold on. Why did you think C was 52?
Isn't it alternate exterior to 52 degrees to go down the line?
Well, we don't have any other. Oh, there's the 52 degree angle.
Yeah.
Yeah. You're absolutely right. It's 52 degrees. I'm not sure I labeled that one 52 degrees. Yeah, I did. Okay. So, yeah, because that's parallel to that. You're right. Alternate exterior. So C is 52.
And then line 3 and line 4 are also parallel to each other.
Right. So let's do that. Double parallel, meaning they're parallel but different sets of parallel. What's D? Because they tell us that that is an isosceles triangle.
Oh, let's see.
Do you need me to make a list on the right here of all of these, or if I just label the diagram, is that sufficient?
No, that's fine.
Okay. So let's look at that triangle. That's an isosceles triangle. What does that mean?
That means that the other angle opposite of C would also be 52 degrees.
Yeah, I don't know that that's opposite of C, but those are the two base angles.
Right, my bad.
And now what is D?
76.
Right? The magic number in geometry is 180. So you're always subtracting from 180. It's a good talent to have. Now that we know that's 52, what's B?
52. Or my bad.
What do they
One,
call? What are those
100.
angles called?
Um,
They're
no.
a linear pair. But more importantly than what they're called is what do they add up to?
180 degrees.
Always. What's B?
128 degrees.
Okay. Now that we know B, we know A. Of course, we knew A was 128 anyway.
Mm-hmm.
Because it's a linear pair with that 52. All right, let's see. What else do we know here? We know L1 is parallel to L2, and this one is 70. What's M?
Is
Here's the principle. The principle is when you have two parallel lines and a transversal. You create 8 angles, but you only create 2 unique angles, and those 2 angles are always supplementary. In other words, every acute angle is equal to the other acute. There's 4 acute angles here. They're all equal to one another. There's 4 obtuse angles, and they're all equal to one another. And the acute angle and the obtuse angle add to 180. That's the only thing you need to know about parallel lines.
Okay.
So, therefore, if this one is 76, what is G?
76 degrees.
Correct, because we have a transversal against those 2 parallel lines. Frequently with geometry, the difficulty is figuring out which is the transversal, because you have all these lines intersecting. And sometimes lines can be transversals as well as part of parallel lines. Now, if H and this angle are the same, what must H be? In other words, what do the 3 of those add to?
180.
Okay.
So you can subtract 76, and then you get 104.
Okay.
And then you just divide it by 2.
Yep.
Then it'll be 52 degrees.
On both of, oh man, on both of those. So that's 52, and that's 52.
Could we get E?
Yeah. E has to be what?
104.
Right. It's supplementary with this angle 76.
Mm-hmm.
And the reason I know is because that's acute, that's obtuse.
Gotcha. And then we can get F, right?
Correct. F is obtuse. Here are that's a parallel with that, and that's the transversal. So F and 104 are alternate interiors. What are we missing? We're missing K.
Could we get M? Oh.
N? Is that what you said?
M.
N or M?
M as in Mary.
Where is M? I don't seem to know.
You forgot to draw it in. It's the angle between K and N.
Hold on, let me pull up my... Yeah, I see it. Yeah, what is M?
Would it be 110?
What is K?
70.
What is N?
In
other words, what's this angle right here? vertical to this 70?
Oh, 70.
Right. So that's an important principle. So what is n?
58 degrees?
Correct. And that's it, isn't it?
Well, we have to get I.
I. Well, let's see. This is 70 here. This line right there is a transversal of these two parallel lines. So this has to be 70 also.
So
Oh,
140?
excuse me.
That
has to be 110. Adjacent angles are supplementary, not equal, which means this has to be 70, which means L has to be what?
40 degrees?
I think you got it down. I think you got it figured out. 180 is the magic number. If you have a line segment like this and you have 5 different angles, 1, 2, 3, 4, 5, they have to add to 180, no matter how many you have. In other words, if you just have one, they have to add to 180. The biggest thing is this parallel thing right here. Now, as long as they give you the parallel lines and the transversal is at a significant angle, like I draw it, then it's real easy to just match acute angles to acute angles. But sometimes they can try to be clever and they'll give it to you like that. And now, we don't know that that's perpendicular. It looks perpendicular, but they don't draw a right angle there. So now it's kind of necessary that you know alternate interiors are equal. So 3 and 6 are equal, 4 and 5 are equal, alternate exteriors are equal, and so forth. So it is somewhat useful, but it's rare that you get this. Usually they draw the transversal at a significant angle, just like in this problem here. All of the transversals are at a significant angle, so it's real easy to figure out, well, one's acute, one is obtuse. Any angle you see that's acute is the same. Any angle you see that's obtuse is the same.
Okay.
That was the only problem on this page here?
Yes.
All right. Oops, I don't think that this is the one I want. This is the one I want. Yeah. And I'm going to flip it twice. Okay. So are these the only two problems we have tonight?
Yes.
All right. These are doozies. I mean, these kind of geometry problems are generally 20-minute problems for sure, just because there's so many things you have to do. Now the question is can I talk about this without redrawing it?
Yeah, I think so.
Okay, I tell you what, you have this paper in front of you?
Yes.
Go ahead and you label it as we talk about it.
Okay.
And then I'll try to keep pace. It may be hard for me, but I'll try. Because usually I need to see one of the angles before I can calculate the other one. Let me look at this for a moment. Yeah, let's see. We got L3 and L4 parallel, L1 and L2 parallel, just like before. And this is a right angle. I'm looking for a place to begin.
Yeah.
All right, I see a place to begin. How about you? Better if you see it.
I think so.
Okay, where would you begin?
Well, I know that we have an isosceles triangle and 72 degrees,
Right here or right here?
both.
Well,
Kind of.
this is not isosceles.
My bad. The isosceles was on the left.
This is.
Mhm.
But unfortunately, they don't tell us A yet. So we do know that this angle is equal to that angle.
Mhm.
But we need a letter to begin with. Since we have to answer all of the letters, let's focus in that same area. What is angle A equal to?
Angle A is the same as the other angle with the 72 degrees.
Okay, what else? You're right. Angle A is the same as that because they're markings. But we have a parallel line L3 with a parallel line L4, and this thing is the transversal. What does that mean? In other words, let me see if I can draw just that part of it. The difficulty on all of these parallel lines is they throw in so many other lines that you can't see it. Okay, there's point C. This is angle A. And that's 72 degrees. Now, if you look at only that, what is A equal to?
72 degrees.
Because it's alternate interior. Yes. So, A is equal to 72. What's this angle?
72.
What's B?
142 and 180.
144 is 72 and 72.
38?
36. In
36.
other words, yeah, this one was 72.
Gotcha.
Which means this one is 72, which means together they add to 144. And the three of these have to be supplementary. So this one has to be 36B.
Okay.
What's C?
C is... Oh, we can get... Oh. Oh, okay. Would be 144?
Uh-huh. And notice that C is also vertical with the sum, with that angle right there. We already knew that was 144.
Okay.
Okay. So now that we know this is 72 and this is 72, what's D?
36?
Yeah, B and D are the same.
Oh,
As
okay.
they should be, because we have parallel lines. B and D are alternate interior angles to
And then we can get
the parallel
J.
lines L3 and L4. And what's E?
E's 144.
Okay, now what's F, based on the fact that this is an isosceles triangle?
Oh, F is 18?
Correct. What's
Okay.
G? This is kind of an interesting problem in that this is rare, where they design the problem where you actually progress through it in the direction of the letters. That's unusual. Usually A is not the first thing you can figure out. It's, some other letter.
Right. Would it be 162?
Correct. In other words, that one's 18, making G 162. And H is what?
144.
Same as E. Was that 144? In other words, I'm not. Yeah, this was 18, 18, 144. Yeah, H is 144. HI, where's I? I must be the next thing we can figure out. come I don't see an I? I see a J. Where's I?
I don't know.
Huh. Oh well. J is the same as what?
J is 36. Same as B.
Same as B, exactly. Maybe they didn't put an I in there. That's actually smart to leave the I out because it gets confused with these hash marks and, you know, the number 1 and all kinds of stuff. So
Right.
I don't see an I on there, but I think we killed that problem. In other words, there's nothing else to figure out there. Did we need this 90-degree angle? I guess so. Oh, J.
Yeah.
Hey, no, we didn't do K yet.
No. Want to be 36? The angle is corresponding to C.
That's 36 there.
And then that's 90, and then subtract that from 180, and we'll get 54.
Correct.
Okay.
Always remember that when you're dealing with a right triangle, the two acute angles are complementary, meaning they add to 90. You don't need to actually go up to 180. It makes the arithmetic a little bit easier. In other words, once I know that angle right there, then I'm just going to figure K is 90 minus that angle.
Gotcha. And then we can get M, right? Because you know that A is 72.
Geez. And L. There must be an L. Oh, they left L out there for the same reason they left out I. Yeah. M is...
Well, if we take A, that's same as 72, and then you subtract that from 180, I think you get 108, and then you divide that by 2, and you get 54 degrees for M.
Well, now hold on.
Oh, no, my bad.
This angle is 54 degrees. Notice that M is very obtuse. So there's no way M is 54 degrees.
Oh, my bad. The two angles next, the base angles are 54 degrees.
Correct. The base angles. In other words, once you know A is 72, then you know the sum of the base angles is 108. Each one of them is 54, making M 126. Yeah, they left out I and L, which I love that they left them out.
Why is that?
Well, because an I and an L look too much like a 1, and we already have lines that have the letter L.
Okay.
So it's just clearer when they don't put in I or L. And that's rare. Usually you see them. Connor, I think you have a pretty good handle on these parallel lines, isosceles triangles, linear pairs. And that's what these were all about. Do you have more problems?
I don't.
Okay, we can go a half an hour tonight if you want.
Okay.
I do have one that is kind of similar. Finding it's going to be the problem. Yeah, this one right here. Very similar.
I already did this one.
You already did this one? Okay. Cool.
Yeah, like a few days ago.
We don't need to do it then. But it's based on exactly the same things. Parallel lines, isosceles triangles, and linear pairs.
And what our teacher taught us to do, which is kind of another hint, is not looking at one triangle, but multiple triangles. So like the isosceles triangle, which A is in, after you find that, you'll be able to find the larger triangle, which B, L, and F are in.
Yeah, this is actually a perfect example of where A, you can't figure out first.
Right.
In other words, the way I started this problem was immediately figured out I.
Mm-hmm.
Okay, once you figure I, now you can figure this angle, and now you can figure A.
Mm-hmm.
And then go from there. You know, A is the same as F. B is the same as L. And you notice in this problem they used the letters L and I. And
Right.
this L is a little confusing. When I first looked at it, I was thinking the number 1.
Right.
So I like the fact that the other problem left out I and L. I mean, why do they need all the letters anyway? So.
Right.
All right. Well, boy, you sound confident on this stuff, too. You feel like you know it?
Yeah, this is pretty easy. I'm just not that good at proofs, I guess. But,
well, you know, here's the good news. You're probably beyond proofs. Once you get through proving congruency,
mm-hmm.
there's not much left to do with proofs. The next thing you're going to talk about in triangles is similar triangles. And the only thing that makes triangles similar is angle, angle, angle.
Mm-hmm.
And you're going to deal with the fact that, you know, proportional sides are proportional. And there's not a lot of proving to be done left. So I'll bet you don't have to do more than one proof the rest of the year for geometry.
Well, that's awesome.
Yeah, and proofs are also something that you never have to do on an ACT test or an SAT test. Proofs are something you need to do for geometry class while you're doing proofs, and that's it. You may take a semester final where you have to do a proof.
Mm-hmm.
And that's probably it. I'll bet you do not have to do any other proofs between now and then. But I can't guarantee that. But that's typically the way geometry goes. They torture you with proofs to start. And I'm not sure why. It tends to demoralize most people and has a negative effect. I think they'd be far better off teaching just the normal geometry first and then go into proofs.
Right.
But anyway, all right, Connor, I guess.
I'm sorry for booking an hour.
What's that? Oh, no problem at all, especially on a Sunday night. I don't have anything after that anyway, so I can go have my dinner sooner. So I have no problem with it. All right?
Well, thank you for your time.
You're welcome. Have a good one.
Okay, you as well.